Alright, I don't know how well this is going to go, but we're going to give it a try. So, the parent equation here is the parameter equation. Remember, A is our vertical stretch, vertical compression. H moves left and right, and it's the opposite. K moves the function up and down. Alright, let's make a table. Alright, notice in our table that, first of all, here's our equation, 1 over x. If you go to your table, notice that when x is 0, we have an error. Let's take a look at the graph now. Okay, if you'll notice here, at x equals 0, we have a vertical asymptote at x equals 0. A vertical asymptote because the function is undefined when x equals 0. So when x equals 0, we have an error. And this tells us that we have a vertical asymptote because we cannot divide by 0. Now if you graph these points, you're going to get something similar. I'm just sketching it. Something similar to this. And that is your rational function graph. Okay. It says, what is different about this function? Linear, quadratic, absolute value, square root. I want you to think about that and come up with an answer that I can check next time I see you. Is the graph continuous? Well, let's take a look. If I put my pen down and I trace it, can I trace the whole graph without lifting up my pen? No, I have to lift it up and put it up here. So it is not continuous. Okay, what is the x-intercept? Well, if you look on this x-axis, notice the graph does not seem to cross it, which means that there's probably a horizontal asymptote right here. Okay, so there is not one, none. There is not an x-intercept for the parent function. How about the y-intercept? Again, there is none. Okay, what is the domain of the graph? Well, it goes left infinitely and it goes right infinitely, but it jumps over what number? 0. So we want to write two intervals, and it looks like I skipped a question. I'll go back. One interval going from negative infinity to 0, but not including 0. Then we'll use the U for union, meaning there's another one. And then we'll pick it up at 0, but not including 0, and going to infinity on the right. And the range, again, if you look at this, lowest to highest, negative infinity, positive infinity, and it jumps over what value? Yes, it jumps over 0. So the range is going to be the same. Let's go ahead and save this question for you. I think we've already answered that question. And that one's for you to think about and answer. Now, would you read this to yourself, please? Notice a dotted line. Notice I use a dash line. That works as well. So we also said that there is one here as well. I'm going to use dash. So we have a vertical. Alright, so we have our vertical asymptote and our horizontal. How many asymptotes does this function have? Obviously 2. Give the equation for each. Let's start off with our vertical asymptote. Lines that go up and down start off with what? Do you remember? X equals 0. Okay. All other lines start off with y. So this one's going to be y equals 0. Now, these values are related to our parameters. So this value will always align with the h in the parameter change equation, and this value will align with k. So what do I mean by that? Well, let's look at this example. What's our h value? 3. So that means that our vertical asymptote would be x equals 3. Our horizontal asymptote, remember, that aligns with k, and our k value is 2. Alright, turn the page over. Thankfully my voice and my coughing is holding off, so let's keep going as long as I don't breathe too much. Now, it says sketch the graph of each rational function. Each graph should have at least 2 accurately plotted points. Remember to use dotted lines to draw asymptotes. State the equations of all asymptotes and give the domain and range. Well, notice the a value has a negative. Do you remember what transformation a negative has? That's right, it's a reflection. It's a reflection over which axis? If you don't know, turn it over, look at the parent. Notice it was in the first quadrant and the third quadrant. Now it's in the fourth and the second. So it went over the x-axis. Okay. So otherwise everything else is the same. I did not put my asymptotes in or plotted the points, the 2 accurately plotted points. But I expect you to do that. Number 2. Here we have a reflection again, but this time we've translated 2 units up. Now, what point do we move to move this function up? Best thing to do is start off at 0, 0, that point right in the middle, and move that point left and right, up and down. So this is going to be our special point, the point in the middle, the origin. So we're going to move that origin straight up 2. Does it go left and right? No. So once you've gone up 2 units, you can immediately draw in your asymptotes. Make a plus. So we made a plus. We have our horizontal and vertical asymptotes. Alright, describe the change. Okay, so we shifted up 2 units. Let's talk about plotting the 2 accurate points. Since our a value is 1, it's negative. So you're going to go to that center point, and you're going to go over 1, and you're going to go down 1. So that's going to give you 1 point. And then you can go ahead and draw in your graph. Now to get the other point, you start in the middle, you go left 1, and you go up 1. And that's how you get your two accurate plotted points. Look at number 3. Is there a shift left and right? No. Up and down? No. So our starting point, our 0, 0, stays the same on this one. Okay. But our A value is 8. So starting in the center, we go over 1. It's positive 8, so we go up 8. 8. Okay. Now, it's an inverse variation, so as x gets bigger, okay, y is going to get smaller. So we're going to have a graph kind of going like that. And on the other side, go to the left one, and we're going to go down 8. I don't know where it is. I lost track, but you get the idea. Now notice as x gets bigger, y is getting smaller. So we have a vertical stretch. Okay, the rest are up to you. Good luck. Hope to see you tomorrow. Don't forget, we're taking a test on Monday.